Haha, I didn't this morning. Ah. Okie dokie, how are we all doing today? Today, we are going to cover use cases. So we're going to go into detail on how to create them. We're going to talk about what the different components mean, how they're put together, kind of some best strategies for figuring out what a good use case is. And before I forget, I want to mention that I did grade your homework last night. I noticed there was a good chunk of you that didn't turn anything in. So if you are one of those people, please reach out to me and we'll figure something out so that you don't have, hey, it's afternoon now. Um, we'll figure something out so that you don't have a black hole in your points. And for those of you, actually, I think there is very few in this class. Um, if you got 0 for the proposal aspect, um, basically, you lost 50 points for not doing the proposal. That was one of the last questions in the manual. You will have a chance to make those back up very soon. To show I'm not completely heartless. I understand things are kind of crazy right now, so not in my world. Could either be a location thing or just that it's always morning. But yeah, you will have a chance to make those proposal points back up. And another announcement too, so let's see, pretty much everybody's here. I'll mention this again at the end, but we are going to have no stream on Wednesday. So I'll be at another conference. Should be the last one of the year for me. So barring any craziness, we should have streams for the rest of the semester. But Wednesday you'll have an out of class lab to work on. So basically you'll have things to occupy your time that we would normally do in class. And if you're one of the people who didn't do the proposal, that's part of your points are going to be baked into that. So I will send out an announcement probably tomorrow to get you all up and running with that, individual or group lab. I haven't decided yet. I'm waffling on that. There will probably be a component for each, honestly. That way I can make sure it's not completely wasted time for you all. It'll be like the last time though, where I give you a manual to work through. And it would normally take a class period, but since things are a little bit more flexible now, you don't necessarily have to work on it from 1 to 2. But yeah, I should be holding my office hours though Wednesday, so that shouldn't be a problem if you have questions at all. I think I just have to give a presentation from like 10 to 11, at some point between 10 and 11, and then I have to participate other times. But yeah, and that should be, again, hopefully the last one for the semester. But yeah, so today we're going to talk about use cases. Oh yeah, your thing tomorrow is going to also, it should kickstart the midterm push as well, because we have initial demo time coming up soon, so that will have some details for you on that as well. And I am not on the right screen. Here we go. So today we're going to talk about use cases. So I kind of alluded to them last time, right? I had my little figure here. So this is a use case diagram. We're going to basically talk about how to build one of these today. And I'm going to come back to that in a little bit as well. Oh, just go nuts, Google. All right, so we're going to talk about what they are and why we would want to use them, why they're useful, and why they're not just wasted effort in the software engineering process. We'll talk about how to actually build the diagrams. Again, there is a structured syntax to them, so generally we have to try and follow that, especially if you're going for like an automated tool where you need that syntax. For this class, we're not necessarily going to be plugging them in, so you have a little bit of leeway with how you create them. It should still represent a UML use case diagram, but you'll have a little bit of flexibility there. And then we'll also figure out how to actually kind of capture it and turn it into a real useful object rather than just a little picture. Okay, so first and foremost, what is it? All right, so a use case gives us a nice high-level view of some particular aspect to your system. Now, I struggle saying function or aspect or component because these all mean very specific things. in terms of software development. Because aspects are something in aspect J, and functions are, your functions, right? But it is some package of functionality that we have. And the use case is going to be generally fairly high level. It will encapsulate everything you need to know about this function in like 2 or 3 words, right? So it'll usually be like a verb, noun, log in, um, byproduct, encrypt data, right? So it's going to be very simple wording, but the meaning behind it's going to be immense. So we're trying to really capture some unique, specific functionality in your system. And for a use case, it's going to be arguable. It's going to be specific to your needs for what you're currently looking at. The level of detail may vary. And the reason I'm saying that is you might have a very, very high level use case diagram, right? Like login or byproduct, right? Or something like that. Very high level concepts. Something like that you might use for discussing with management or marketing or customers or something like that, right? It's the very high level details that are very easy to talk about with like non-engineers or with stakeholders who don't need to know the implementation details. You can drill down further with more specific use cases, right? These might be your development products where you're trying to really identify what the use case is doing. So you can have different levels of granularity there. Now, the use case, again, it's some high level function. It's intended to capture a discrete goal. So a couple things in that sentence. Discrete means unique, means there should be one use case describing this function. There shouldn't be two use cases describing the same thing. That would be basically an overlap, and then you should either combine them or separate them out completely, right? You shouldn't have two that are the same thing. So that's kind of the notion that we're getting at here. Capture things at a high level, and we're going to capture them visually at first. So here are a couple of examples for you. Format document, or format a document to be a little bit more grammatically correct. Right, so here we have exactly what we need to know. You're working for a word processor company, right? You're working for Microsoft, you're building the next version of Word, or you're extending LibreOffice or OpenOffice, or any of those word processing tools. Format a document is your high-level goal. You don't necessarily need to talk about font selection. You don't need to talk about paragraph styles or headings or bullets or any of that. That's too deep in the details. We just care about format document. We care about print document, right? So very high level tasks. Or think a little bit more like a hardware or a control logic type of system where you have an elevator control system. And you don't care about what algorithm you're implementing to ideally pick up people on 30 levels, right? You care about request elevator, right? So user pushes the button, request elevator happens. The things behind the scenes are what we talk about either at a deeper level of model or in your requirements. High level use cases are just scenarios here, basically. So if that makes sense, question for you all. I've got a, actually, let me do something behind the scenes here because I need to reset the results from the session this morning. Reset results. Yes, please. Thank you. I'm curious how you think we can actually capture use cases. So, oh my God, where's present? Oh, it's already been a day, let me tell you. Okay, so how do you think, and again, this is from your knowledge, your background information that you may have, how would you capture something high level from either a user or from something detailed like requirements? So how can you generate these kinds of high level concepts by talking to users or by reading your requirements? So questions for you to participate in. I swear my phone always blows up at like 1 o'clock. At 100 notifications, it seems. All right, anybody have any guesses? Look for specific keywords or phrases. Hey, that's a good guess. Definitely. So if you have your software requirements spec, you can scan through it, try to maybe identify commonalities. You know, requirements 10 through 50 describe the user registration system. So we might have a use case diagram for user registration, right? And then whichever keywords, right, that describe particular features, that would be a use case. Again, high level though. Log in, log out, validate, input. High level concepts here. Polls. Yep, another good way to get information, sure. So we can poll our users, poll our stakeholders, for instance. So ask them what they think we should use. Bug reports. Sure, so we can kind of work backwards, right? So if there's an existing system, we can look and see what's working, what's not working, and we can maybe generate new use cases to supplement the existing system or reformat things to fix the bugs, right? So definitely good examples. What about doing things like prototypes? So if we're going a more, middle of the road software approach, or we're doing prototyping, if we build prototypes for our users and ask them what they think about it. So here is a bare bones Android application customer. What do you think about it so far? Well, it's nice, but there's no colors. There's no spinning widgets on the screen. It's very boring. My user is never going to accept this. Okay, well, what do we need to do to make it work for you? Yeah, so then we capture some high-level concepts here. Those could then go back and inform our requirements too. So hopefully you can kind of see how this process can be used to either refine existing requirements, right? So maybe we identify new use cases, maybe we update old ones, or we update requirements and this informs, a new use case. We could also realize that we have use cases that are completely unnecessary, right? So in reading through your project proposals, I got a good feeling for what you're all intending, and I can kind of see what the various use cases would be. Right, some of you are going all out and building a super deep immersive Unity game. Okay, that's going to be very tricky if it was a team of 1 or 2, but if you have, 5 or 6 people on your team, like most of you do that are doing Unity, it's probably more achievable, and I can see how different team members would work on particular features, particular use cases, right? Whereas if you're building, a mobile app or a calculator application or something like that, you can see the other use cases for those as well, right? So that was kind of 2 points there. Use cases are definitely kind of interesting to look at, and I can envision what you're all going to be building based on your documentation you've given me. Plus, you're doing good on your project proposal, so nice work there. Alrighty, so we have another concept to talk about here as well. So goals versus interactions. Goals and interactions are 2 aspects which will feature into the use case concept, but we have a slightly different viewpoint here. So let's consider these points. So if we're going down the document formatting route for an example, we may want to define styles, update styles, copy styles. All right, so copy like your headings, your paragraph styles, spacing, maybe background color, watermarks, right, whatever style we're defining. Let's compare that to format document, or ensure that documents are consistent. If you look at the top one here, it's a lot more detailed, right? We're actually seeing things happen. Whereas here, much more high level. Format a document could really mean anything, which is good for use cases because we have flexibility to define interactions, define implementations later down the road. So the latter, this one here, these are user goals. This is what the user desires, or your stakeholders desire, right? This is your concept that has to be fulfilled. It's encapsulated, it's very well encapsulated. We don't care what the implementation is, that's down the line. Here, above, are interactions. This is what we're doing to achieve the goal that's higher level. right? So if we want to format a document, we have to define styles, we have to be able to update them, we have to be able to enter input, right? So all of the interactions are going to be more fine-grained, right? They're a lot deeper. Now, both of these have a place in the use case model, and it's arguable which ones you include. The interactions are really good for demonstrating how users and systems participate, but if you're looking at a very, very high level, here's your use cases, right? High level goals to achieve. If we're drilling down farther, we're maybe trying to have a more detailed use case model, these might actually be your use cases. It just depends on where the boundary of your system's being drawn, and that's something that we're going to look at here in a moment. So, what do we care about with these goals and interactions? We need to understand what the system's doing so we can capture these goals. Right? If you have no idea what the heck you're doing, you're going to have a very hard time implementing a system. And you say something like that, like, well, that's common sense, of course. You have to know what you're programming. Well, not everybody knows what they're doing when they set out, right? So if you don't have a clear goal in mind, it's very hard to develop something. So these use case diagrams are really great for kind of capturing that need for structure in your program, basically, right? So what the system's going to do is where our goals come from. How the user is going to achieve those goals is the user interactions. Hi, how's it going? You gonna go talk to mom for a minute? Or are you gonna help me present? All right. See, there, you're right there.
No.
All right. Go downstairs, honey. All right. So we're going to take these goals and we're going to refine them. And when I say refine, we're adding more detail. Okay? So goals high level, interactions, refinement. We're getting more and more and more detail here. So let's actually look at the syntax of the model now. Again, UML has a very specific standard for how these models are put together. Let's try to follow that. You get into the automated tooling side, this has to be perfect. For class diagrams, I'm just asking you to kind of free draw them, right? So use one of the draw tools that I gave you, pen and paper, and then take a picture of it. Whatever we can get the concept across in. So use case diagrams, we're going to have some components to it. So we have actors. I've kind of alluded to this already. This is going to be a person or a user or some kind of a human entity, I guess an entity that interacts with your system. That could be a dog or an animal or something if it's an automated system. It can also be another program, right? So an actor can actually be automated. We will try to define if it's a person or a system, but the point is it's some external entity that's interacting. So they're external to the particular system, right? They're not encapsulated in a bubble. These actors are going to have interactions. Hopefully the last slide is starting to make sense now. We have our goals, we have our actors. The interaction between actor and goal is where that interaction is coming from. So the goal of an actor, sorry, the purpose of an actor in these interactions are to satisfy the goal. And satisfy in terms of the software engineering world, that means things are succeeding, right? They're passing tests, they're performing correctly. So life is good for this use case if it can be satisfied. So we have actors. They're going to be little stick figures. We have our use cases. They're going to be little ovals, all right? So this is the goal. A use case should have generally a way to measure the results, but again, they're very, very high level. So format document, how do you measure if that's successful or not? Well, I can apply these interactions to it. All right, so bubbles, stick figures, and then connections, also known as relationships. These are going to be your lines between actors to use cases, or even between use case to use case, right? We can include functionality or extend functionality or generalize your object-oriented paradigms that you hopefully should remember from Intro to Java. We can bring that in here as well. And hey, I spilled tea all over myself this time. It was water during the last class, so we are on fire today. And nobody can see that because it's under the camera. Problem is I added honey to my tea today because my voice feels like it's giving out, so it's very sticky. All right, perfect. So let's actually look at some bubbles. These are use cases. All right, so a bubble is a use case. The whole thing is a use case diagram. All right, so first let's look at these use cases. Here we have a loan application type of example, right? We have, this might be for somebody like a student loan company or a financial trading company or something like that, where we're getting loan applications, we have to evaluate them, we have to close it out, maybe approve them, deny them, generate late notices if you don't make your payment on time, things of that nature. These are all high-level use cases. Things to consider. These are some kind of event. So it's not a flow of information, it's not a flow of processes, it is something that will happen. Right? We'll talk about process flow later on. Like step 1, step 2, step 3, step 4, that's going to be a flow. An event is something that happens or it doesn't happen. All right, so particular, the minutia. Use a verb-noun combination. So this is your kind of standard Microsoft syntax if any of you are PowerShell users. So their commandlets are verb-noun, right? So verb, evaluate, noun, application, or the loan application, I guess. Be an adverb. Application, loan. I had this problem in the last class too. I'm trying to remember my middle school grammar sentence. Why am I spacing on this now? Any of you ever have to do the grammar figures where like the noun goes in the front and then you have a little line, then your verb, and then your direct object and all that fun stuff? It was my 6th through 8th grade and I loved it back then. That's why I'm so hard on grammar now, I guess. So these use cases are going to be, again, discrete. So evaluate loan application will have no feature on closing out the loan. Okay, so enough harping on that. Here we have the full thing. We have our actors. All right, so we have a cashier, we have a customer, and basically here we have a point of sale system. Mad Libs. No, it's sentence diagramming is the word I'm looking for. It's kind of fallen by the wayside in terms of popularity, but let's do a quick little Google image search. Sentence diagram. Yeah, there we go. This was my jam. So this is how you learn proper grammar. Or you take a sentence and you break it down into its components. I actually enjoyed this. It shows you how weird I am. But anyway, full screen, please. Thank you. So here we have a point of sale system. So if you've ever done any kind of cashier work, you probably have interacted with point of sale. Here you have an actor that's the cashier and an actor that's the customer. All right, so here's two people, two stick figures. If we wanted to include an external entity that is not a person, you could either do a stick figure or a little box with actor in text. So I actually had an example of that from last time, now that I think about it. So here is my little use case diagram describing a video game. Loading state, so there's my player, and here are some actors that are systems. Both versions are fine for me. I'm sure each UML version has a particular affinity for one over the other. But if you're going to do a box like this, you still need to denote that it is an actor. Otherwise, it's an object. So I tend to like the stick figures, honestly, a little bit better myself. All right, so we have people or actors. Our use cases are internal here. Our connections or relationships are these lines. And then this box here is your system boundary. So the system boundary is actually very important to draw. And it just looks like a box right now, right? Nothing super exciting. But what this box is demonstrating is where your point of sale system ends basically our view at the POS system and where, the rest of the system would begin. So we only care about this particular group of things here. There might be other aspects to the system, right? There's going to be a whole supply chain behind a cashier, right? We need the warehouse infrastructure, we need management, we need buying, selling, all of the stuff that goes into running a store. This is just one little slice, right? We care about this small detailed view at the customer interaction. So boundary will actually constrain your view here. So what do we care about in this particular aspect? We care about being able to buy things. We care about being able to refund things. And we want the cashier to be able to log in, right? Because if the cashier can't log in, they can't sell you anything. They can't refund anything. What do you notice here, though? And I just said there's an order that's kind of implicit, right? Point of sale systems don't work if you don't log in because you need that employee ID tied to a sale. But here there's no notion of ordering. Come on, pointer, please come back. Thank you. Ordering comes later. We don't care about order until we start drilling down. So again, these are atomic objects. These are separate things that can happen. What else do we see in here? The customer interacts with buying an item. The customer can refund an item. The customer does not log in. Obviously, this is different now that there's a membership for each and every store in the world, but the cashier logs into the system, the customer doesn't. So what we can take out of this model here is that if we're adding code or we're adding requirements or other models, we're going to have code to handle all of these things. But if we go back and look, there should be no customer input on the login system. And if that's something that we detect, well, clearly there's a problem somewhere and we have to fix that. But again, a figure like this, we can easily communicate with people on our development team and our management staff exactly what our point of sale system is doing. Looks really simple. And making these is really not all that hard. It takes some time to get into the idea of kind of going high level, but very important part of the process, I think. And just for a little bit more information here, your boundary, again, is this box, and these are your use cases. The whole thing is a use case diagram. Does the notion of a boundary make sense? So if we want to set up a POS boundary here, which is fun to say when you know the other meaning of POS, again, we're constraining what we care about. We don't care about resupplying the back of the store. That's another system. All we care about is the cash register, the cashier, and the customer. Can actors be inside of a boundary? Good question. No, actors should be outside of the boundary. That's why setting the boundary is important, because we want use cases to be contained. I actually had a question from my grad students, because we're also talking about use cases in that class. Can you include one use case diagram in another? Because intuitively, that would make sense. Can there be multiple boundaries? You're going to have multiple use case diagrams. So if you have a UML or a use case diagram where you need to include another one, or you need to draw multiple boundaries, that's a very good indicator it's gotten too complicated. So you really need to constrain your boundary. And the kind of the guideline, so rule of thumb almost, is that you have 3 to 8 use cases inside of a boundary. Any more gets too complicated. Any less is not enough information. Again, take that for what you will. Your specific instance may be different, but these should be fairly straightforward diagrams. Now, if you want to include other functionality, there's no reason you can't reuse use cases, right? Like if I have a point of sale system and I want to include like the warehouse, I'm probably going to have a login bubble in multiple diagrams, because we share a common login function. Nothing wrong with reusing use cases. But later on, when we get to actually writing out the pros of these documents, so there will be like a by item use case description. there should be only one description for that, but we may have to add a little bit extra wording for the different actors touching it. And this is just another example of setting a boundary. So here we're only looking at the customer perspective. But did that answer your questions? Again, there's a very specific structure to these things. But on the other hand, it's kind of funny because I was doing some research on this last night to make sure that I fully understood some of the nuances of use case diagramming, because there's some of the more advanced techniques with it. And one of the Stack Overflow answers was, keep in mind this is only a standard, UML can be extended for your own purposes. So I would say follow the standard. If you get into a very unique situation, then you can consider extending the model. All right, so we have our actors, we have our use cases, we have our boundaries. And again, we're describing kind of one particular aspect of the system here. You're going to have multiple use case diagrams. This is another example of a use case diagram. I just wanted to show you, kind of well, there's the textbook that I didn't make you buy for this, but not like one of these types of examples. So this actually comes from a Medium article that somebody wrote up, which is all you need to know about use case modeling. So if you're looking for a little bit more of a deeper dive into UML modeling for use cases, it's a decent read. Kind of gives you a nice little blog type format of how this all works. But here we have, again, the same thing. So here we're doing a airline passenger service. Here are the people that we have. So check-in person, we have a customs person, we have passengers, and then we maybe have a baggage system, right? So here's all of our high-level use cases that we have for this particular system. We're not necessarily going to get into public and private types of things. It depends on your flavor of UML if you want to use that. I'm just going to assume all of these are more or less public, except they're constrained to this boundary. But again, kind of just another view of things here. We can also extend UML with our object-oriented paradigms. And again, not limited to object-oriented, but you're including, you're extending. We have generalizing as well, which we'll get into more with like class diagrams. But we don't necessarily have to encompass everything in a single use case. So here's another example where we actually take that point of sale system and we extend it. So think of this model effectively as expanding the boundary for the last point of sale system model. Here we don't have a client in the loop though, so we have a different viewpoint. Okay, so we have your salesperson, which could be your cashier, or it could be like the salesperson on the floor trying to sell you something at like a furniture store, or just remember going to Circuit City back in the day when that was more of a thing, and the people there would get commission for helping you, right? So that's your person on the floor. But here we also have people on the back end. So a trading manager and a trader. Maybe we have to figure out current stock prices to buy our products, right? So the trading manager is going to be setting the limits for what you can buy. The trader is going to be there figuring out which particular products to stock your store with or buy stocks in something, or whatever they have to be doing here. We're going to have a system. So this is one of those examples where a automated system is just a stick figure. This will be automatically updating all of our accounts as things happen. So a little bit different of a viewpoint on maybe a similar system. So what do we care about here that's kind of interesting? Right, so we still have stick figures, we still have lines touching bubbles. So again, these are going to be your interactions with these goals, right, with these use cases. But we have a couple of other things going on here. So we have includes and extends. So let's say that I want to analyze risk or find out if there's a deal on some product out there. Well, each of these use cases is going to have some method for evaluating value, right? So assessing value, it's called valuation. But basically here is a use case where it's describing some function or feature, and we're just going to add it to our analyze risk, or we're going to add it to our price deal, right? So if I pop back over here to my example model for you from my game, I have a way to initialize my game. I also have a way to generate the next level of my game. Well, every time I generate a level, I have to initialize the state of that thing. And I'm just going to include that functionality, right? So think of it like your standard include in your programming languages where you're reaching out, pulling down functions or variables or something like that. You're just bringing that in to use it. Exact same notion here for use case diagrams. The flip side then is going to be extending. So whereas include, we're bringing in functionality, extending, we're basically taking some basic functionality and we're adding to it, right? So we're extending it. So if we have a limit exceeded, we might be getting a deal where we can extend some functionality here. So I've got some verbiage here to kind of help break this down a little bit more. Sorry for the slanty line. This caused problems in my last class because it wasn't perfectly symmetric. But let's just call it, I'm trying to throw you all off here. So include, we have some packaged behavior that we can include in other use cases. The connection is that we're bringing that functionality in. Right. This is one way that you can actually simplify your diagrams too, because you have some common component that you can reuse. So I gave you valuation as an example in that picture. You could consider like sanity checking or sanitization, maybe some kind of a drawing function if you're doing a game, or draw or generate map, right? Or any kind of include functionality would work here. So it's reusable code. Extending is, again, where we have two use cases are similar, so we're basically extending it to do something slightly different. So here I have a standard use case, and maybe I have some non-standard functionality, right? Like maybe I'm handling an error state where I don't expect the error state to happen, but if it does, here's my functionality to handle that. It's generally a good idea to kind of try to capture that if we can as well. This type of functionality actually will help improve your understanding as well, because we're going to get, a notion of what the system has to do. Here's all of our use cases. And even when we talk about implementation, here's all of our reusable components. So we can start identifying this early, right? If you look at a model like this, okay, replace these bubbles with something you're more familiar with. Maybe if you're not into stocking warehouses or anything like that, right? If I realize I have some component I need to reuse, I can probably start defining an API where all of my system components know how to call this module, right? Like I know what function parameters it's going to need. I know what return values it's going to need. We're not showing implement details in here, but I can start thinking about it, right? And I can communicate with all my stakeholders, all of our aspects of our system we care about. Making sense so far? Got one more thing to talk about with this now. All right, so we have the lovely pictures here, right? Everybody can understand a good picture. Is this useful for communication? Absolutely. If we have an automated tool, absolutely, right? And when I say automated tool, I realize a good chunk of you have no idea what the purpose of an automated tool would be here. Let's say that I draw a use case like this. Boop, 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 boop. I can maybe automatically generate code from this, or I can automatically generate documentation from this, right? Let's draw our bubbles and our actors and our associations. And okay, maybe I'm not putting in specific code for how this would work, but I can generate function stubs, or maybe boilerplate code that I know goes with this, right? So that's kind of where automation can be interesting. Or I can start automatically generating documentation or test cases or all of these mundane activities you have to do. We can use stuff like this to automatically generate it. And there's various tools out there. We'll probably look at some of the more common ones like baked into Eclipse or Python if I'm feeling frisky. But very useful things here. All right, so if we are all good with that, last thing we have to talk about is how we actually make this detailed now. So we have this use case diagram here. This is the one from earlier. I think I need to move myself up a little bit if I recall, because I was hiding stuff last class and I didn't realize until we were almost done. But this is our point of sale system. There is not a lot of detail in for the developer, right? There is not a lot of detail for, say, like that traceability thing we talked about where everything has to be linked. Well, we're going to take this and we're actually going to extend it into a formal document. All of software engineering is going to be formal documentation. I apologize in advance, but that's the preview of your future. So our POS, which is really fun to say, let's look at the buy item use case, right? So that's this guy right here, buy item. We're going to break it down into a use case description. So you have a use case diagram, has our actors, has our connections, use cases. A use case description is going to highlight a single use case in a model. And remember, I mentioned earlier, you can use use cases across multiple models. So this is going to have to capture that if you're, reusing it later on. So we care about the title, so by item, so we know what it is. Who are the actors associated with it? Well, we have our customer and our cashier. Oh, remember when I mentioned earlier that we don't have a notion of timing or priority or steps? We're starting to get that in here. Who initiates this use case? Well, the customer does, right? If I want to buy an item, I may look at this figure and say, okay, I want to buy an item. We have a customer and a cashier. Who starts this off? Well, the customer brings a product to the front, right? Intuitively, I can get that, but here we're actually going to start spelling it out. We also have a description. Customer arrives at checkout with items to purchase. Step 1. Cashier records the purchase items and collects payment. Step 2. On completion, the customer leaves with the items. Step 3. Right, so here we actually have a stepwise procedure, a flow that we're describing being spelled out. This is your basic description. What's the use case? Who's associated with it? What are the particular flows? I'm going to start using the term for this particular use case. This is not, again, it's more detail. It's still not super helpful. We have an expanded use case description, and this is where things get a little more interesting to me. Here is where we start filling in the holes for ordering, for traceability, and basically everything we need to know at this level of granularity. So again, use case, still there, buy item. Actors haven't changed, right? Who's initiating it, who's participating, any other details we need to know. Parenthesis fields can be flexible here as you need. Description hasn't changed, at least in this view. New things, cross-reference. Which requirements is this use case tied to? Now we start getting more interesting, right? If I have a use case called buy item, here are all of the requirements it's tied to. Well, now I have a direct reference back to, lower level details that I can use to program this thing, or that I can use for generating test cases or validation or verification activities or auditing. And if I realize, hey, I've got nothing to cross-reference this use case to. Oh, now I'm hiding the arrow here. Sorry. It's the next one that I needed to move it for. Nobody told me in the chat. Glaring at you all now. Okay, so let's say I have no requirements to reference. What does that mean? Well, either A, I'm missing requirements, which is bad because we have a missing hole in our document, or B, this use case is utterly useless. Why do we have it if it's got no requirements it's tied to? What's the purpose of this feature? Well, we have no support for it, so let's remove it, or let's include it elsewhere. right? So when we start adding in this notion of traceability between other artifacts, we start seeing how the whole project works together. Another thing we can get, what are the preconditions? And a precondition is what has to happen before this particular use case is executed. You can also have post conditions for what has to follow on later on. So cashier must have completed the login use case. All right, let's go back to our model here. Again, no notion of ordering, but if I want to buy the item, the cashier has to have logged in first. Otherwise, there's no way for the item to be recorded as being bought. All right, so if you've ever gone to the grocery store and you bring your food up to a human to check out, they have to be logged into their terminal, right? Otherwise, how's it going to know which cashier sold you that product? So we get a notion of ordering here. We can even go a little bit further. So let's take our description, and instead of having a paragraph, which is up to interpretation of the reader, let's enumerate it, right? 1, 2, 3, or ABC, whatever your preference is. But here, excuse me, we get a notion of exactly what has to happen in which order. It's still in prose, right? So it's still technical writing where we can actually expand a little bit here, but here are the steps that have to happen. Cross-references are still there, preconditions are still there. So basically we have a good idea of what has to happen. With a use case description, you can take the use case diagram and give it more weight, right? So the high-level graphics are going to be for your stakeholders who just need to talk about maybe interactions or goals or program basic things, and then the use case description is where you start hardening your various models, various specifications. All right, this is where I had to move. All right, let's go in between there. Why do we care about these and when do you use them? Generally, it's going to be always good to use a use case diagram, honestly, even if it's just a mental exercise to get your project structured. You know, if you're doing something without requirements, you know, you're just kind of free coding like you probably would on most term projects. If you can codify a little diagram, that really helps structure you mentally, right? If you're on a formal project, like you are all now, these are going to be tied to requirements, they'll be tied to test cases. We have a way of very easily communicating what your project is doing. Not only that, you can figure out who the users are, what systems will be interacting with your use cases, any code reuse possibilities, your dependencies. This can all be described here. And if you think this is completely wasted effort, keep in mind how easy it is to miss basic functionality or easily overlook trivial bugs which blow up in your face later on. If you go through a phase like this, more often than not, you're going to catch a lot of the low-hanging fruit in terms of bugs or faults or interactions that you may not have expected. So the thing I'm going to leave you all with is consider everything I talked about today. You know, use case diagrams, descriptions. How would you use this for your term projects? So start thinking of different use cases that your projects are going to have. Right? I made you write basic requirements as an in-class assignment, right? You had to do your project proposal. You're getting high-level wording. How would you take that and codify it into a set of use case diagrams? Right? What use cases do you need for your game or for your mobile app or your web app? Right? How are you going to codify this? And that's the spoiler that we're going to have to be doing this very, very soon for your term projects. So, anybody have any questions for him today to kind of sum it all up? If not, again, if you joined late and you didn't catch the beginning of the stream, there will be no class stream on Wednesday, as I'll be away. I will send out an announcement with what you'll be doing in my absence. So yeah, other than that, I will see you all on Friday. Office hours should still be held on Wednesday, just in case we need to chat. But other than that, thanks for coming by, and I will, yeah, I'll be around if you need me. So, have a wonderful day, everybody.